Hello, this is Mrs. Lewis again. Today we're going to talk about how astronomers go about hunting for planets out of our solar system. Those kinds of planets are called exoplanets because they're not part of our solar system. You know that we are part of a galaxy called the Milky Way galaxy. And this galaxy, if we were able to look at this galaxy from the top, we would see it as a rotating pinwheel in space. Here's where our sun is on that galaxy right here. And that sun is going to go around, orbiting around this galaxy and pull us around, but it's going to take a long time. In 250 million years, we will go all around the Milky Way galaxy and come back to where we started. If we looked at the Milky Way galaxy from the side, we would see a very different view. It looks very, very flat, and it's very large. It is from all the way over here to here, 100,000 light years. And you remember that a light year is the distance that it takes light to travel in a year, and it's going very, very fast. When we look at the Milky Way galaxy from Earth, it looks like this. It's made up of 200 billion stars, but those stars are actually very far away in this very, very large galaxy. And in between the stars, there's lots and lots of dust. So if we were trying to find the stars with light telescopes, that would be very difficult. But it's a good thing that we have radio telescopes, because radio telescopes can collect information from these stars, and they're able to see through all of this dust inside of the Milky Way. Well, with the radio telescopes, we've been able to plot some things on the Milky Way. So here's the Milky Way seen with a light telescope, and then this is information that we can get about the various optical features that we see on the different arms of the Milky Way galaxy. And so what we need to do now is we need to go to these stars that we can find in the Milky Way, and we need to figure out if there's any planets orbiting them. There are two methods that astronomers have come up with to figure out whether a particular star has planets orbiting it. One of those methods is called the radial velocity method. And this method is based on the gravitational attraction between the star and its planet. We know that any two bodies have a force of gravity between them, and that's true for a planet and a star. But since the star is much, much bigger, it exerts much more force on the planet than the planet does on the star. However, there is some force that the planet exerts on the star, and so what happens is that the star is actually orbiting around the center of gravity between the planet and the sun, or the star. And so the star is going to orbit around the center of gravity, which is very close to it, and the planet is going to orbit around the center of gravity, which is very far from it. And so what we see from Earth is this little orbiting of the star looks like a wobble. And we analyze that to see that there is a planet causing that wobble. The other method is called the transit method. And that method is based on the fact that when a planet goes in front of a star, between us and the star, the light that's given off by that star is going to go down a little bit, because the planet is going to cause that amount of light to dip down here. And we have some very delicate instruments that we can use to measure that. Let's talk a little bit more about the radial velocity method. So when we think about a star and its planet, we're going to remember that they are orbiting around the common center of mass. So here's a very large star and a very small planet. And so the center of mass is right here. Sometimes the center of mass is actually within the star, kind of toward the edge of the star. But what happens is that this center of mass is going to be the center of the orbit. And so the star is going to orbit like this, and the planet is going to orbit like this. If there were no planets, there would be no force of gravity pulling the star, and there wouldn't be this little orbit which we see as a wobble. If the planet and the star are oriented in the right direction, like this, then we're going to be able to see the wobble as when the planet is here, it's going to pull the star a little bit toward us, and when it's over on the back side of this orbit, it's going to pull it away from us, and we're going to be able to detect that using the Doppler effect. The Doppler effect affects what we see of the light coming from a star. If a star is going away from us, then what happens to the light that it's sending us is that light gets spread out and the wavelength increases. And therefore, when the wavelength gets longer, the color moves toward the red, and we call this the redshift. If the star is moving toward us, that actually compresses the light wave that's coming toward us. The wavelengths get shorter, and that is a blue shift, and the light coming toward us looks a little bit more blue. Here we see a star and its planet, and this star is wobbling here as it goes around the center of mass, and in this case, it's going away from us, so therefore we have a red shift because the wavelength is increasing and the light curves to the red. Over here, in this case, the wobble is making the star come toward us. That's going to compress this light wave, making it shorter, and we see a blue shift. So when we look at the stars, if we see this red and blue shift, then we know that there's a planet around that star. The other method for figuring out whether a star has a planet is called the transit method. And this method is based on the fact that when a planet goes between the star and us, the brightness of that star is going to have a little dip in it as the planet goes across. There is a telescope mounted up in the sky, and that telescope has a photometer on it. The photometer is an instrument that measures the amount of light given off by stars, and it measures the amount of light given off by 156,000 stars up in the sky at one time. This telescope is orbiting around the sun the same as we are, and it's kind of like following us in our orbit, and it's looking at the sky, at a little tiny piece of the sky, about 1/400th of the sky, and measuring the light from all the stars. Kepler sends us information about these stars every 30 minutes. It measures the brightness of the stars over that time, and it sends that information to us. Now, those stars are a long ways away, somewhere between 600 and 3,000 light years away. Kepler has a photometer that's so sensitive that it can detect a dip in the light of the star that's only 0.01% of its light. And by figuring this out, those stars that have a dip in their brightness, we figure have planets going across them. So far, we've found about 2,000 planet candidates. And this information about the dip in the brightness also gives us some other information about the star. We can tell its size or mass. We can tell how long it takes that planet to orbit the star. We can tell how far away from the star it is, and we can tell its temperature. With that information, we're able to decide whether that planet might be in this green habitable zone. And that information is very valuable to astronomers.